first of all, thanks to everyone for coming. Hope that this will help anyone and everyone, no matter where you are at, whether you've been flying for 25 years and have thousands of hours. Could be a good refresher, maybe even some points of contention, perhaps. At the same time, perhaps we're on the opposite end of that spectrum where everything still feels brand new. So there's lots to discuss, but the whole point, of course, is that while there's plenty of topics to take a look at, certainly if you think about them cognitively and you think them about continuously, you mull over them, you chew on them, that's, of course, how that turns into more of a, where you want to be, more of a habitual state where everything, specifically what we're talking about tonight with approaches and landings, is more automatic. For those of you who are working on becoming an instructor or are recently mentored instructors, then of course the benefit is we can take these approaches and continue to think about how we can teach them in our own style as well. On top of that, be aware for all of you CFI applicants and newly minted instructors, there's also the important concept of the fact that not only do you want to be on the lookout for these things with your customers, your students, but you also yourself can make sure that your students are aware of these complications in addition or on top of course, what we're looking for. So how can they actually recognize some type of faulty approach or a landing, and of course, they therefore know how to correct for it, but more importantly, how to avoid it in the first place. So let's jump in here. So what we're going to talk about tonight specifically, of course, we have the specific emphasis and concern in relationship to accidents and incidents. This is just a quick breakdown from the latest Joseph T. Now report. I believe it's 2015 is the latest date or the latest year that we have data on. That if you total up all the accidents for that data that they developed, yes, 43% was in the approach and landing phase. So in this case, it is the highest percentage of at least these listed 4 categories. Other types, of course, kind of amasses quite a bit of various concerns. I've got, for examples there, weather and maneuvering. The good news is that this is also the lowest fatality rate. So while it's the highest rate, it's also a very low fatality rate. So we're not talking about concerns in relation to that specifically, but obviously we're close to the ground. We have a high workload environment. Lots of concerns pop up there. So in association, we're more likely to encounter, excuse me, different types of issues that can lead to an incident or an accident. Namely, damage to the airplane is really what we're concerned about here. So a lot of people's concerns are warranted. There's hesitation there. There's anxiety in relationship to the approach and the landing. What we're going to talk about tonight is to hopefully clarify some of the mystique, if you will, of the situation so that it doesn't seem as otherworldly to you. Tonight probably won't be the only solution, of course. It's not going to be a silver bullet, but my hopes is to get your minds thinking through some of these things, to be more aware of them. Again, that, you know, if you had a landing in the past, you still to this day have no clue what happened. My hopes is that this will clarify some of that, take some of the mystique away, as I said, and from there, make approaches and landings less of a mountain and more of something that seems more attainable. Specifically what we're going to talk about, we're going to break our concerns down just the same way. As you'll see, we're going to base a lot of our studies off of the Airplane Flying Handbook. So the Airplane Flying Handbook basically breaks down the faulty approaches and landing types into 4 main categories. We have energy management, we have timing issues, we have hard landings and nose wheel landing concerns, and we have directional control issues. Specifically, if we break those down, in energy management, we have issues with low final approaches, high final approaches, being too slow or too fast on approach. The timing issues, of course, we can see high round outs, low or late / rapid round outs, floating and or ballooning during a round out. In the hard landing and nosewheel section, we've got bounce landings. We've got issues with landing flat that can lead possibly to a porpoising landing. We also have some possibilities with wheelbarrowing and just generally what a hard landing concern, of course, has in relationship to us. Specifically, of course, when it comes to the condition of the airplane. Directional control issues, touchdown and adrift. So this, of course, usually occurs with a crosswind. It doesn't have to. We have issues sometimes where we can accidentally begin to drift due to our aileron control inputs while we're attempting to round the airplane out or flare the airplane into a touchdown attitude. We also have issues with touching down in a crab, where the alignment of the airplane is not correlated with the runway. So the airplane is misaligned when we touch down. Other crosswind concerns, wing rising after touchdown. And of course, if we have time, we'll discuss the ground loop shortly, but won't spend too much time about that other than just discussing what it is, as ground loops aren't too common in tricycle landing gear airplanes. So for any of you out there that are flying tail dragger airplanes or conventional gear, as opposed to tricycle, ground loops, of course, become a bit more of a concern in those situations. All right, so our first category, lots to cover, so we'll jump right in. We're talking about energy management. Namely, of course, what we're talking about in this situation with energy management is really broken down into two categories: airspeed and our approach angle. As we just saw before, our main concerns with these two issues, of course, is either being too slow or too fast, and quite simply too high or too low on approach. Now, as anyone who's been to any of these meetings knows, I try not to just simply present material to you. The idea behind these sessions is to kind of show you again where we can pull this information up. If you've been around the school long enough, you know that many of the instructors, Ed, certainly coming from the top down from Ed, is that our main job is to make ourselves obsolete. So again, we don't want you just taking the information that we tell you and regurgitating it. We want that to be internalized and become your own personal conviction. And one of the best ways, of course, to do that is to investigate some of the information on your own, not just, again, from the word and the mouth of your instructor. So specifically in this case, we can find some of this information, of course, in Chapter 8, specifically Chapter 8 of the Airplane Flying Handbook. So let's jump to the Airplane Flying Handbook real quick and take a look at what, of course, it has to say in this case. So, excuse me, if everybody see that? Been having issues with this today. Give me 1 second. There we go. All right. So starting off in faulty approaches and landings, in this case, low final approach. Again, if you're unfamiliar, this is the Airplane Flying Handbook. Looks like this. You can find this if you use ForeFlight. You can download it directly. And specifically, if you wanted to find where we're looking today, head to the table of contents. So let's jump to the table of contents real quick. We're looking in Chapter 8 right now, approaches and landings, specifically 8-27. So we'll jump ahead to 8-27 again. And we're talking about a low final approach. Now, we're not going to read this together specifically. Of course, this is where you'd find the information, but let's just touch base on a couple of things, of course, that can complicate our approach and lead to a low final. One of the most common things I see specifically on progress checks that lead to low final approaches is a lack of awareness of where the winds are. Namely, in this case, usually the winds are fighting us on a base leg position. And on combination with that, usually the downwind was too wide in the first place. So let me draw something out just to kind of clarify or visualize what I'm saying here. So imagine, of course, this is our runway. This is kind of semi-3D drawing here. So, of course, there's the departure leg, the crosswind, the downwind leg, the base, and the final. The problem is today the winds are blowing out of this direction. We probably in this case are not mindful of that if we're allowing ourselves to get wide on the downwind. So there's our first problem, is maybe we turn the crosswind too late to downwind, or we didn't apply proper wind correction angle on the downwind. So these two combining factors, of course, leads maybe to more like a ground track like that or worse. So we have a longer base leg to fly, and on top of that, our base leg ground speed is going to be slower. So what does that mean to us? It means that if we use the same configuration we always do, our descent angle is going to be steeper. So we're going to end up lower on this approach. So this is one of the main reasons I constantly see low approach angles, specifically on progress checks, is a lack of awareness of the wind. And in reality, the wind is never the same. So the wind today is not the wind tomorrow. And so in association, the more mindful you are of the wind, i.e. in this case, the more you practice being mindful of the wind, asking yourself, where's the wind? How is it going to affect me? And what do I need to do correctively, or more specifically, preemptively? How can I preemptively correct for this wind so that I don't end up getting into these situations? So low final approach is really what we're talking about. This is one of the ways to avoid being low on approach. Another complicating factor, of course, as we all know full well lately, is having to extend our downwind. And of course, if we take the standard operating procedures that we have given to us from the school and we apply them at various distances from the runways and stick hard and fast to those numbers, it's not always going to work out for us. So once again, we have to be willing to adapt to that, to say, you know what, this is going to be a much longer flight path than my normal position of being my desired touchdown point to touchdown itself. And therefore, I may start with these numbers, but I'm expectingly going to have to modify from them. So namely, in this case, if we're talking about a longer flight path, we're really expecting higher power settings to avoid getting low on final approach. This can be, of course, further complicated by different situations, like, for example, if the wind, of course, is down the runway as we hope it to be, well, you may expect to be on glide on the base, but when you turn final, then suddenly you turn into the wind and your ground speed slows, and so in association, your descent angle steepens, i.e. we get low on final approach. Whatever the different reasons, and there are more than, of course, what I've just discussed, we end up being low on final approach. Now, most people can recognize this. I won't go too much into detail, of course, on how to recognize being low on final approach. The key takeaway is, of course, is when at what point have we determined that this is unsatisfactory as far as it being a stabilized approach and need to abort the approach itself and go around and try again. We know from the standard operating procedures that it's 300 feet AGL, but that doesn't necessarily mean you have to wait till 300 feet AGL to go around. So before I say anything else, let's preemptively always acknowledge that the go around is always an option, and in fact should be your first option unless you meet whatever desired satisfactory elements you need. So your mindset, in other words, instead is go around, go around, go around, unless at 300 feet I have A through whatever you want to say, G, level of parameters. You're on speed, you're on glide, you're aligned with the runway with minimal correction needed, etc. Otherwise, it's a go around. So we're low on final approach. The one thing that I want to emphasize, because again, we could discuss this for hours, the one thing I want to emphasize that I also see when people are low on final approach is an excessive commitment. So let's kind of draw this out. Most people, as I said, recognize they're getting low on final approach. Just a quick illustration to kind of visualize what we're talking about. Most people can recognize that as they look out the window, they look down their sight picture, they're using, hopefully, their aim point. Let's say that they pick their aim point wherever it is. Maybe in this case, we're on a very short runway, and sure, our aim point is actually in the grass because our touchdown point is going to be here. So we're looking at our aim point, and we, of course, recognize that we're getting low on approach because we see the aim point moving vertically higher in our windscreen. Most people recognize that. And the corrective action, excuse me, is to, of course, add power. The problem is people recognize this, but they recognize it more habitually than cognitively. What do I mean by that? I mean that they react to it without recognizing they're reacting to it. I.e., instead of the power being adjusted, it's usually the pitch that is being arrested instead. So without even recognizing it, they're beginning to apply back pressure. This can be further complicated, of course, by the fact that maybe there's buildings or trees here and there that are moving higher in our peripheral, and therefore we don't like that, right? When we're flying, we don't want to see things that are on the ground close to us when they're not supposed to be close to us. And so those things further aggravate this habitual response to pull back on the flight controls, rather than, of course, the appropriate correction, that is to add power. Now, at a certain point, you get too slow, you have to abandon the approach, of course. Generally, that tolerance, of course, if we were to think about from the ACS, if we're talking about a normal approach, would be somewhere around 5 knots. It depends on the exact approach airspeed you're using at this time. But if we're just talking about a normal approach and landing, thinking about 5 knots should really be your tolerance before you say, oh, this is a go-around. However, even slowing down 5 knots further complicates this situation, because if we go back to aerodynamics, remember, what have we really done by pulling back on the flight controls? We've increased our angle of attack. And by increasing angle of attack, yes, we produced some more lift, but what we've really done is increase the induced drag on the airplane. So the very thing that you're trying to avoid, i.e. not getting low on approach, is in fact actually the very thing that's going to ensure you get low on approach, because the increased drag will increase your descent angle. And so the power you needed just a moment ago to correct and arrest the descent angle to stay on the desired descent angle, not only do you need to increase it to that amount, you're going to have to further increase it to compensate for that increased induced drag. So what's the takeaway from this? You've got to be cognitive of this and say to yourself, I know that, like most human beings, my habitual response is going to pull back. But instead, constantly asking yourself, is my aim point moving higher on my windscreen? If it is, and I'm on speed, then the corrective action should be to immediately correct with power. All right, so let's talk about the secondary complication with this. Most people, if they do add power, or if we're talking about being high on final approach, will reduce power. But bear in mind that that correction is just that. It's an initial correction. It's not your ultimate and final correction. And if you've ever asked yourself, why do we keep our hands on our power? It's not just because it looks cool, because that's the official pilot body position. There, of course, is a rhyme and a reason behind that. Namely, in this case, we really want to think about power as much of a correction tool as the flight control itself. So we add power in association, but at the same time, we don't expect to leave the power where it is. So let's just take a look at a couple of things real quick that the Airplane Flying Handbook says. So we'll read the highlighted areas. So when it's realized that the runway cannot be made unless appropriate action is taken, power must be applied immediately to maintain the airspeed while the pitch attitude is raised, to increase lift and stop the descent. When the proper approach path has been intercepted, the correct approach attitude is reestablished and the power is reduced and a stabilized approach is maintained. Here's what I also see. I see on progress checks, when someone recognizes they're getting low, they add power. Good. But they don't recorrect. And that's the key takeaway. One power setting isn't the final power setting. Think about adjusting your power in and out almost as much as you would move the flight controls themselves with both aileron and elevator control inputs. You're not committed to one power setting. You add a power setting, expecting in this case that it's going to allow you to rejoin the desired glide angle, and then you expect it in association, you're going to have to reduce the power again. If you commit to a single power setting, you'll probably fly through your desired glide angle and then find yourself now on a high approach as opposed to a low approach. So, key takeaways. Think about adjusting the power continuously as necessary. In fact, if you're first learning how to land, or first learning in this case how to make an approach, don't feel like you've got to get it right. Allow yourself to experiment. Because what actually happens a lot of times is you're so concerned about finding that right power setting that you'll set a power setting and that's it. And in reality, especially with further complications like shift in wind direction as you descend, shift in winds because the winds themselves are moving, or shift in winds because you've got gusting winds, vertical movement of winds for that matter, You can't expect that a single power setting is going to work out for you on at least most approaches. So think more loosely about, I'm just going to experiment with this power setting. I know I'm low, let's add some power. If it's too much, no big deal. I'm going to reduce the power. Test the airplane and learn from that. Don't think you have to get it right off the bat. There's a time to learn so that you can, of course, become proficient. And that time to learn, you should not feel obligated to getting it right the first time. You should feel obligated, if anything, to testing things and experimenting things. Take liberty with that. All right, let's move on. Otherwise, we're going to be here all night. So let's jump back to our presentation here. And the next thing I want to talk about is high final approaches. We're not going to spend as much time as low because, of course, this is the same exact concept, but now in reverse. So this is another common issue I see on progress checks is the concept, of course, if someone recognizes that they're high. So in contrast to what we just discussed, now someone recognizes the aim point is moving lower in their windscreen as they're on speed. And so in association, they will reduce power. Again, don't feel committed to that power reduction. In fact, expect to reapply the power. We even see this as well in the airplane flying handbook. So if I jump back to the airplane flying handbook, you're also going to see that they even give us a specific visualization in this case to show that we are going to reduce power, rejoin the desired glide angle. I'm sorry, excuse me, this one's an addition of power to rejoin the desired glide angle and reduce the power. There's no difference when you're high. If you're high, you've got to reduce the power to rejoin the desired glide angle, but don't expect that power reduction will be sufficient. In this case, the power reduction, if you leave it where it's at, it's going to actually descend through to the desired glide angle as opposed to keeping you on glide angle. So once again, don't feel like the power setting is a singular commitment. Be ready to readjust the power after making that initial adjustment. Okay, before we go on, I want to talk about one key factor or one key takeaway. Once again, with final approaches, guess what? The always go around is always an option. But one thing you need to be aware of course, is what, once again, is considered a stabilized approach. So if you're high on final and you reduce the power and suddenly you recognize that from your current descent, you can make your aim point with the power reduction. Whether or not that is stabilized really depends, of course, on whether it's an excessive sink rate. So, sorry, everybody. Vivian had to make her appearance. So if a high sink rate is continued close to the surface, it may be difficult to slow to a proper rate prior to contact with the ground. Any sink rate, therefore, according to the FAA, in excess of 800 to 1,000 feet per minute is considered excessive. Now, does that mean you need to look at the vertical speed indicator to determine whether you're an excessive descent rate and therefore on a destabilized approach? I'm not going to say yes or no to that. What I would say is with experience, you will develop a kind of a sixth sense as to whether it's appropriate or not. Because if you've done enough correct approaches with input from your instructor, from discussions with your instructor or other people for that matter, you will develop a sense for that. Yeah, if you want to look at the vertical speed indicator to verify, that's fine. Obviously, most of our scan is outside the airplane anyways, so that's not an absolute requirement. What it boils down to, why this is so critical, of course, is if you have an excessive sink rate in association with a high or steep descent angle, usually round out timing becomes complicated. So really what this is doing is helping you avoid complications with your round out, namely in this case, a late or rapid round out. So we'll get to that a little bit later. Again, in this situation, your go around is your first initiative, not your last. Okay, so the next thing I want to talk about, of course, we'll just jump straight to it, is the slow final approach. This usually on its own isn't usually common. In other words, usually you're not slow and on glide. Usually the slow final approach is a result of a low final approach. It's exactly the same reasoning that we just talked about when we're low on final approach in a situation where, as I said before, we're raising the pitch habitually in response to the runway being higher and higher, or specifically our aim point moving higher and higher in our point of view. So the habitual response, of course, is to raise the pitch before adding power. That, of course, increases our induced drag, and that's what's going to slow us down. So usually, as I said, a slow final approach is correlated with a low final approach. The complicating factor you have at this situation is, even if you can rejoin the desired glide angle, which it's questionable whether you'll be able to do that or not. And by the way, we're well below 300 feet, so we should have gone around by now in this visualization. But the idea is, if we're dragging the airplane in, then the airplane's ability or energy is entirely dependent on the power. What do I mean by that? It means that if any point in time you reduce the power, the airplane's response will be to sink rapidly towards the ground, or in other words, in this case, descend quickly through our desired descent angle. And so what you end up having to do is carry power long into the approach, as opposed to if you're on glide or even slightly above glide, it allows you more altitude to reduce the power earlier in the approach. In this type of situation, if you drag it in, you have to carry power pretty much right into the round out. And as I often tell my students, the problem with this is you've got to reduce the power, and in association, you've got to time or deftly control the flight controls so as to allow you to touch down properly, i.e. time the round out and the flare properly. That's easier when this has already been taken out of the equation. So as you all know, or should know, excuse me, this is good timing. As you all know, if you reduce the power where you're supposed to, in other words, when your aim point is made, then the power is moved out of the equation, and you simply are just flying the airplane's resultant lift to the ground. If you're carrying power late into the equation, then it's kind of like solving a two-variable equation. In other words, it's kind of like solving running out of space here. Obviously, I didn't give you enough information there, but the idea is this is your flight control, this is your power. If you compare that to a single equation, like well, obviously that's a lot easier. So what am I getting at here? I'm getting at that if you leave power late into the round out, or late into the approach, or even worse, into the flare, and you suddenly reduce the power, it's much more difficult to adjust on the flight controls in response to that. So that's the complicating factor, among many other things, that a low and slow final approach complicates. But in this case specifically, just one of the things that I often see is the low, slow final approach requires someone to carry power late into the approach, and when they reduce the power, it's very difficult to manage the round out and the flare. It takes more deftness of control, and ultimately it takes more experience to be able to develop that ability. So why even test that? Just use a normal approach, make things easier for yourself. The key takeaway, of course, with the slow final approach is the very difficulty of lowering the pitch. You must reduce the angle of attack, because not only in a slow final approach do we have the complication, as we just saw, of getting lower because we increase the induced drag on the airplane, but as we can see in the airplane flying handbook, the bottom section here, the wing is operating near the critical angle of attack. So obviously we have a concern in relation to stalls. This is really just not a place to be. In fact, if I gave you my opinion, there's no reason to continue an approach on a slow and low final approach. Just abandon the approach, go around, do it again. This is not a place to experiment because, as I said, you're reducing the parameters of safety, and it makes it much more difficult for the rest of the approach for that matter, but also, as we're going to discuss, getting into the round out and the flare itself. All right, so let's jump ahead to our next section. So we're moving past energy management into round outs. Specifically, though, let's talk about them before I present them all together. So ultimately what we're talking about here is timing issues. So in this case, timing, sight picture is key for proper timing. But as I often try to emphasize, a mental procedure. In other words, when are you going to look? Where? When are you normally reducing the power? And then, of course, ultimately touch. And touch, admittedly, does come with practice, but it also comes with proper procedure. I.e., in this case, as everyone who flies with us knows, we should have the airplane properly trimmed. Namely, as the SOP states, at least 2 to 3 wheels of trim, so that the flight control is light in your hand. You can't have good touch on the flight controls if you're constantly fighting the airplane. So a relaxed grip is really key in this consideration. So by utilizing some of those procedures that we'll discuss specifically, because for most people, we eventually get the approaches down. We can recognize when we've destabilized the approach and we just go around. That's a solution. But now we're getting closer to the ground. Things that get a little bit more complicated, requires a bit more deftness of control. And in this case, there's less standard operating procedures for it, because when you're close to the ground, it's more of a feel than it is necessarily a procedure. That's not entirely true across the board, as we'll discuss, but touch, of course, is a key element. So we're going to talk about high round outs, namely why high round outs usually commonly occur at a training level. We're going to talk about late or rapid round outs. We've already talked about one of the causal factors for late or rapid round outs. We're going to talk about another one that I commonly see. We're also going to talk about floating or ballooning during round out and the complications, of course, that can occur there. So let's jump back in the Airplane Flying Handbook, and then we'll just go through those together rather than jumping back and forth, just to save a little bit of presentation time here. So let's jump back to the Airplane Flying Handbook now. And we'll start off by talking about that high round out situation. Specifically, what is it about the high round outs that we see occurring? Why would someone round out high? Before I answer this question, I do want to see if I can poll some of y'all. So let me see if I can get this thing to work. It hasn't been working the last couple of times. So everyone should see the poll there. Go ahead and take a moment and answer that question for me. And I want to see if I can get what I'm expected to get as far as the response goes. So I'll give it about 2 or 3 minutes and poll that while I continue to talk about the high round out. So specifically in this case, let's just read together in the Airplane Flying Handbook. Continue the round out further reduces the airspeed and increases the angle of attack to the critical angle. This results in the airplane stalling and dropping hard onto the runway. To prevent this, the pitch attitude is held constant until the airplane decelerates enough to again start descending. The question is why do people round out high in the first place? So let's kind of talk about this. Lots of things are going on in a pilot's mind. Namely, in this case, what we've been recently referring to, of course, is that aim point on the runway. So let's say in this case, I've picked my aim point to be just past the runway number, and I become super fixated on that, right? Because that's, of course, as we just talked about, what helps me determine whether I'm descending through my desired glide angle or moving above my desired glide angle. The problem and complication with this is too much fixation on that, or even our touchdown point beyond that. I.e., in other words, what ends up happening is as we move closer to the runway, we continue to stare in over at that aim point. Forgive my illustration, it's not the best. But as we move closer to the runway, we've got our scan still focused in on that aim point. And maybe we're even following the proper procedure. The proper procedure in this case is we're on glide. We recognize that our power should begin to be reduced as we recognize we can make our aim point. In other words, we can begin to glide to our aim point by transitioning the power out to idle. So, can you guys see my screen?
We're still looking at the plane.
All right, there we go. Well, I've been basically drawing for myself. All right, great. All right, so what I was saying here before is the nose is too close to our aim point now. If we stare in over the top of our nose at the aim point, then our depth perception is askew. We need to begin to, as we reduce the power, we time that association to begin to reduce our scan over the nose and out towards the end of the runway. I.e., in other words, in the same way that, as I commonly refer to, it's like leveling your eye line with a table. If you're trying to see exactly as you lower your head where your eye is in line with the table, you don't look at the edge of the table that you're closest to. You look at the end of the table to determine your alignment. This is the complication that occurs that leads to a high round out, where we stare in over our nose still at our aim point, or maybe our touchdown point again beyond it. So when do we reduce our scan at our aim point and move it out towards the end of the runway for proper depth? It's when you begin to reduce the power. And when you begin to reduce the power, when you recognize that the aim point is made. So you're done with the aim point at that point, basically. You begin to close the throttle back. You recognize you have the aim point made, and your eyes are drawn out towards the end of the runway. The end of the runway begins to give you depth perception as you move closer to the runway. And don't forget also, secondarily, another way to interpret your depth, in addition, is as you move closer to the runway itself begins to envelop your peripheral. So you're looking out here, but your periphery, you can still see that the runway is moving sideways out around you as you move lower to the ground. Those are your two key takeaways, that you scan towards the end of the runway for proper depth, but also use your peripheral to recognize that when the runway moves outwards and envelops your peripheral, or in this case, envelops at least the width of the nose, you get good depth perception that that's the time, of course, to begin the round out. If all the while, all you've been doing is staring at your aim point instead, it's going to fool you into thinking you're closer to the runway than you actually are. And this is usually the most common culprit for why a high round out occurs. In other words, I see high round outs usually associated with crosswind landings. Why would that be? Because during a crosswind landing, we're focused on alignment, right? So we're aligning the nose relative to the runway. So we're looking at the nose to its immediate surroundings. The trouble is, that's going to skew our depth perception up. So instead, we've got to divide our attention to not just alignment, but also continuing to look down the runway for proper depth perception. So be aware of that. That's another common error I see on crosswind landings, is while someone's trying to manage the crosswind, it leads to a high round out. So get those eyes down the runway and you're moving them down. Tell yourself, okay, closing the throttle, walking the throttle back as the aim point's made, eyes to the end of the runway for depth perception. That will give you good timing to avoid a high round out. Of course, if you do have a high round out, what's the recovery? Well, the book says hold the attitude you have, or relax some back pressure to reduce the attitude so as to allow the airplane to begin to descend again. This is a judgment call. And early on when you're first learning landings, there's not a lot of room for judgment. So it's best, of course, that you first consider the go-around. Again, that's our first option. And avoid, of course, a stall too high above the runway. Once again, even it in the book says it is recommended that a go-around be executed anytime it appears the nose must be lowered significantly or that the landing is in any other way uncertain. So your go-around, as you can see, is always your first option. And guess what? It's going to be the first option for all of these complications. All right, we've got some polls in here. Nobody fell for my last answer there. So yes, it looks like a lot of people are still, a few people are concerned about the difference between the round out and the flare, understanding the difference between the round out and the flare. And the second element would be the confusion between the whole aim point and touchdown point thing. So we are definitely going to address both of those. And so I think actually this is a good time to do it. So let's stop for a moment. I'm actually going to open it up for questions after I kind of delve into this, and then we'll move on. So before we do, let me draw out a couple of things. Okay, the first thing is okay, so what in the world is the difference between the round out compared to the flare. Because a lot of people say the round out and the flare, right? And yes, if it's done properly, they do move fluidly together where one just transitions smoothly into the other, where you almost, as an observer, couldn't tell the difference. But for those who are first learning, you do really want to separate them. In other words, when you're on approach, you really want to think you have 3 phases. You have the approach phase, and just simply drawn, that of course is our approach angle. But then you have the round out phase following that. Most people skip this and are thinking this immediately. The problem with that is our airplane is flown at an airspeed, or more specifically at an angle of attack, that is buffered above the critical. More specifically, what that means is the airplane's not immediately ready to stall with any further increase in angle of attack. In fact, we have some time to go. And so the airplane's not immediately ready to land when you begin to level the airplane out over the runway. Otherwise, we would immediately transition into a flare attitude. So instead, you have to think about dissipating the energy. And how do we dissipate the energy? With the round out. So we go from our approach to our round out phase. Now this is exaggerated, but if I were going to break it up, this is the approach phase, this is the round out phase, and then maybe that right there, this is the flight path of the airplane, not the attitude of the airplane, would be the flare. Again, this is exaggerated, but just to bring the point across that you do really want to think of these in separate phases. We think first approach, and we focus on the approach to make sure we're on a stabilized approach, as we just talked about for some time, on glide and on speed. But the round out cannot be skipped. So what are we thinking in the round out? Usually you're thinking about settling the airplane in ground effect. Now, once again, even that's an exaggeration, because pretty much immediately as you begin to level the airplane out in the round out, it will start to descend anyways. However, your mentality, if you're finding yourself struggling with one of two things, either you're rounding out too late and you're too close to the runway and you land flat, or you're rounding out too late and you're too close to the runway and you overcorrect and you balloon back away from the runway, that's usually a sign you might be rounding out too late, because you're not thinking about the round out itself. You're thinking about, how can I land this airplane right now and have a soft touchdown. So change your mindset a little bit when it comes to the round out. The round out, truly, if we're going to talk about it from a first learning standpoint, is I need to arrest the energy of the airplane before I can let this airplane land. If I continue straight ahead on my approach, obviously I'll just impact the ground at, in fact, in this case, my aim point. We would just crash right into the ground. But at the same time, I'm not going to touch down until I'm here, the second X, because the airplane still has quote unquote excess energy. And that excess energy comes from the fact that we approach with some safety buffer above the critical angle of attack. And that's that excess airspeed, if you want, in this case. So the excess airspeed allows us to fly at a lower angle attack to keep us safely above a critical angle attack. But therefore, the airplane's not going to be ready to land. You can't immediately expect the airplane to be ready to touch down. That's what the round out is for. The round out is to keep you from crashing into the ground at your aim point, allowing you to dissipate the energy of the airplane. And of course, depending on how succinct you are with your desired approach airspeed, that will actually determine how long the round out quote unquote is. And of course, that's where we get into a float, as we'll talk a lot about it here in a little bit, where we're coming in too fast sometimes, or we apply too much back pressure and we round out or balloon back away from the runway. So again, if we really want to differentiate the round out from the flare, the round out is the initial dissipation of the energy of the airplane. The flare is the continuation, that as you descend further towards the ground, you're rotating into a touchdown attitude. If it's done perfectly, 2 and 3 almost seem like the exact same thing. But for most people, when you're first landing this, change the mindset and think of them differently. In fact, as I'll show you at the end, think about the round out as if you were going to do slow flight down the runway. Most of you probably have done some slow flight down the runway. If you haven't, talk to me about this afterwards, or send me an email, and we can discuss that, or talk to your instructor about it.
It's the concept that a round out really should be, okay, the only difference between a round out and slow flight down the runway is the difference of adding power, not adding power. That's the difference between, say, the round out and the flare. So a round out, leveling off above the runway at the appropriate altitude above the runway. If we added power, we turn it into slow flight down the runway. If we don't add power, then the airplane continues to lose energy, descend towards the runway, and that's where we respond by continuing into the flare attitude or the touchdown attitude. So hopefully that clarifies the difference between the round out and the flare. I'll open it up for questions in just a second, but let me continue right into the aim point compared to the touchdown point. And in a way, I actually already just answered what the aim point compared to the touchdown point difference is. Again, the aim point is what you're aiming for, that if you didn't round the airplane out, you just literally crash right into the runway at that 500 feet per minute or so descent rate. Whereas, therefore, because we carry excess energy above the stall, the airplane's not going to be ready to land, and so we round out and we transition to the flare, and the difference between the aim point and the touchdown point is that distance there, because the airplane has excess energy. If you were flying an airplane where literally you were right above stall, you're just below the critical angle attack, then your aim point would pretty much be, if not exactly the same as your touchdown point. We don't do that. We carry a buffer for multiple complications, gusty winds, inaccuracy of approach airspeed, etc. And therefore, we know that there's going to be a difference between the aim point and the touchdown point. So what that looks, of course, like to us out the window, excuse me, is if I want to land here, I can't aim there. In other words, that should not stay affixed in my windshield. I have to aim somewhere short of that. And of course, the difference between the two depends on the airplane you're flying, the configuration you're flying. But if you're flying a Cessna 172 with full flaps on normal approach airspeed, the rule of thumb is generally ground speed times 5 in feet. So if your ground speed is 60, then it's approximately 300 feet difference between where you should aim here compared to where you should touch down here. Okay, so anyone is allowed, if you want to just unmute, ask me a question about anything before we continue on. If you want to ask it afterwards, if you don't feel comfortable asking in front of everybody, that's perfectly fine too. Hopefully I'll last that long. It sounds like I might need some water. So any questions before I go on? All right, let's continue on. So with that being said, now that we've differentiated the difference between a round out and a flare, we've talked about the high round out. Key takeaway again, when your aim point is made, move your eyes out towards the end of the runway and associate the timing of that movement, usually with your initial reduction of power, to begin focusing on depth perception. Yes, as we talked about before with a crosswind, you can't stare only at the end of the runway. You've got to look back and over the nose to make sure that the nose gives you signs that you're properly aligned. But when you're thinking about depth, therefore your eyes are kind of moving back and forth between the nose and out towards the end of the runway for depth perception. What about a late or rapid round out? As we talked about before, if you're on a steep descent angle, in other words, in this case on a high approach, you could be experiencing such an excessive descent rate that it's very difficult to time the round out. And this leads to a later rapid round out. So what do we really mean by a later rapid round out? Most of you have probably seen this before. You're maybe distracted with the crosswind, or the descent rate is suddenly increased because of a shift in the wind, or whatever combination of events, and suddenly you recognize, wow, I'm way closer to the runway than I initially thought I was. And it looks like we're careening towards the ground. And if we don't do something immediately, the nose wheel is going to kind of hit the ground first. And so we pull back to arrest the descent in association. This is kind of the most extreme example, and this could certainly occur with an excessive descent rate. But as we'll talk about, it often commonly occurs because of what we just talked about before, where people are mentally skipping the round out. So what to do in this situation? Well, if it's an excessive descent rate and you nearly hit the ground nose wheel first, then the best solution, of course, is a go around. a common saying that I like to use is landings were not meant to be saved. So we're already outside of what we expect to want to see. We want to see a normal approach, a normal round out, a normal flare. Anytime we deviate from that, our corrective action, our first go-to action is a go-around. That being said, let's say that it's just slightly late. Namely, in this case, let's say it's because we forgot to think about the round out. We were focused maybe on our aim point. We're thinking about the crosswind, and we just suddenly realized, wow, I didn't focus on my depth perception when I began to reduce my power. And so I wasn't scanning the correct location, and suddenly I realized I've rounded out later than I should have. What's the big deal about a late round out if I just am closer to the ground than I should be? There's a couple of complications. The first of which is you're going to be fast. You're going to be too fast, too close to the ground. So if you visualize this, the airplane has very, very little distance, right, between the runway and the wheels themselves, and you've got a lot of airspeed or a lot of energy to dissipate with no altitude to compensate for. So you pretty much, as I often say, you have to have a crystal ball here. You have to perfectly begin to rotate the attitude of the airplane up before you have even signs that you should rotate the attitude of the airplane up. Because if you don't, you land flat and fast, which we'll talk about. There's lots of complications, especially with an efficient wing like a 172, where you land fast and flat. Or if you get it wrong, you start to balloon back away from the runway. And so that has, of course, its own complicating factors in the fact that now you're moving back away from the runway while rapidly decelerating and therefore rapidly increasing in your angle of attack. So stall concerns in that situation. So a late and rapid round out has lots of complications, from either actually allowing the airplane to land flat or the opposite, ballooning back away from the runway in the first place. So we avoid a late or rapid round out by A, making sure we're on a stabilized approach at the appropriate descent rate. As we saw with the FAA, they recommend in the Airplane Flying Handbook, nothing more than 800 to 1,000 feet per minute, kind of dependent on the airplane. Otherwise, it should be a go-around. The secondary concern is a distraction, which we kind of talked about. That can just happen. Look, this is just a reality, and that's why the go-around is always an option. You should always commit to the go-around first. The third thing is what I alluded to before, and this is what once again I see commonly associated, in my opinion, with flat landings on progress checks, is usually they're rounding out too close to the ground because they didn't think about the round out itself. They think, I've got to get close to the ground and land the airplane, instead of thinking about, I need to round out somewhere about, everybody has a little bit of a different number, 3 to 5, maybe 10 feet above the runway. And why is that? Why do I want more distance above the runway? Well, if the airplane is situated here, that's an exaggeration, but just stay with me here. Then from that rounded out position, as the airplane continues to vertically descend, as it loses energy, you looking down here will see that occurring. And you've got the ability to respond, because the vertical movement of the runway is in fact your cue point to tell you, okay, I need to continue to rotate the attitude to a flared touchdown. In other words, that extra 3 to 5 feet gives you that ability to recognize that. You don't have to have a crystal ball anymore. You can respond to what the descent of the airplane is telling you. That again, as it vertically moves downwards, you recognize that as your reference point. As you look down, the runway is moving up towards you, and you respond by rotating the attitude in a flared attitude for touchdown. In other words, that is your tool. In the same way that when I respond by lowering the pitch to level out by referencing the altimeter, this is now my instrument. My instrument is my depth perception based off of my sight picture down the runway. Once again, if I'm too close to the ground, I don't have that. I've got to just know the airplane so well and have such a good deftness of touch that I can just time it habitually without even having a reference to tell me that. So that's the key takeaway with rounding out too close to the ground, is you don't have any tool to tell you when you should rotate the attitude of the airplane. And that's why usually low roundouts lead to the two most common results: a flat landing or a balloon back away from the runway. Obviously, in this case, let's read what the book has to say a little bit before we go on. You're going to be not surprised, of course, that once again, they recommend considering the go-around. So this is, of course, in the section under a later rapid round out. We can see that they refer once again at the end, otherwise the pilot should execute a go-around immediately. But before that, suddenly increasing the angle of attack and stalling the airplane during a round is also dangerous. From that situation, of course, that it may cause the airplane to land extremely hard on the main landing gear and then bounce back into the air. So this is back to the most extreme example. This would be either because you were on an excessive descent rate or you were more likely distracted with something and recognized real late that you're about to impact the ground and you pull hard back on the flight controls. Be aware of this complication that, in fact, trying to arrest the descent may, of course, lead to an accelerated stall in this case and lead to a hard landing. Certainly, if this ever occurs and you bounce back into the air, once again, a go-around should be executed immediately. So if we haven't seen the reoccurring theme already, think go-arounds first as a preemptive action, and only when everything else is met as a requirement do you continue. Okay, let's move on to floating during round out. So I didn't talk earlier about fast approaches. Fast approaches can create complications from an excessive lift issue, so you end up being high on approach as well. But really the biggest thing to take away from a fast approach is the complication it leads to when trying to land the airplane, i.e. you have too much energy. The airplane doesn't want to land. And so it leads to an excessive float where we land well past where we want to land on the runway, or even worse, we try to force the airplane onto the ground before it's ready to land. So if we just read the AFH in the highlighted section, if the airspeed on final approach is excessive, it usually results in the airplane floating. Before touchdown can be made, the airplane may be well past the desired landing point and the available runway may be insufficient. This does happen. There's actual accidents that occur. Why did that pilot land that airplane so far down the runway? Because the go-around isn't the first thought process in the mind. In fact, in many cases, it's never even considered. It wasn't taught maybe during their initial training, and it certainly wasn't practiced following that. And so it's just not part of their repertoire or their tool set, if you will, to solve problems when it comes to landings. As we just talked about, landings are not meant to be safe. So if you're excessively fast on approach, you can expect every single time to float excessively down the runway. The only saving grace you might have is a strong headwind that reduces your ground speed and ends up allowing you to float in the air, but not necessarily move laterally across the runway excessively. Let's talk more about the bigger concern, though, and that's, of course, trying to force the airplane onto the runway. So let's just write out a couple of complications that, of course, can occur. We'll talk about them more here in a little bit. But especially with the 172, it does not like to land before it's ready to land. So if we force the airplane onto the runway, we have a lot of complicating factors. One, the landing is going to be flat. Now, I remember when I was first training that I liked flat landings. I seemed to have the softest landings when they were flat, rather than every time I got the nose up, I'd kind of plop onto the ground as I stalled onto the ground. So despite what my instructor said, back in the back of my recesses of my mind, I thought, you know what? I don't know what they're talking about. Flat landings seem to work for me. So what is the big deal about a flat landing? Well, as I already said, they're going to be fast. So what does that mean just from a standpoint of longevity of brakes and tires? It means you're going to be using the brakes more, which means the tires are going to wear out faster. The brakes are going to wear out faster. But also with flat landings, you have directional control issues. So now, because you're on all 3 points and you're going faster than you normally should, the airplane becomes less stable about its directional control. The rudder inputs become overly responsive, as opposed to when you at least reduce the weight on the nose wheel, much less have the nose wheel off the ground. Then we get into even worse situations like wheelbarrowing, which we'll talk a little bit about later. If I didn't spell this right, I'm sorry. And then the worst of all would be a porpoise situation. I think that's how you spell porpoise. So the porpoise situation is definitely the worst case scenario, as we'll talk about a little bit later. There are more things we could really get into in the nitty gritty, but when it comes down to it, flat landings are particularly problematic when it comes to fast approaches that either lead to, once again, a float rather, or you try to fight that float with excessive energy and make the airplane land. Specifically, usually this occurs when you're trying to make a touchdown point, i.e., most commonly during a short field landing, but even on a normal landing, since we have a tolerance on a normal landing. This is another no-go. Look, it comes back to that aspect. If we didn't meet the parameters we set for ourselves, a go-around is our first option. So be aware of the complications of trying to force a floated situation onto the ground, especially with an efficient wing like a 172's wing. As you can see, what do they recommend? If a landing cannot be made on the first third of the runway, that even goes beyond what we just talked about, and not considering a touchdown point, then you should, of course, execute a go-around. All right, so ballooning. We kind of alluded to that again when we talked about a late or rapid round out. This can still occur when there's an incorrect input during the timing of the round out and or the flare. Ballooning, even if it wasn't because of a late round out, can oftentimes occur when you're first trying to get a feel for the airplane. But guess what? It often usually occurs as well when people don't have the trim set properly, because you have a lot of control pressure in your hands, you're fighting the airplane, and it's very difficult to feel that, once again, I kind of say deftness of control, to feel out just the correct amount of control response or control loading you need in association with timing the round out and the flare. So you're fighting the airplane and you're not getting what you want. So then you increase even more, and that control input is excessive and it leads to a balloon. Why are you ballooning specifically? Well, if you think about it, what's really happening, I've used this before, so again, anybody that hates math, bear with me. But again, lift is equal to, excuse me, the coefficient of lift, which I'll explain here in a second, times air density in the atmosphere, whatever that is, times velocity squared, times the surface area of the wing. So when you're landing an airplane, let's just get rid of all the stuff we don't really care about that are constants. This is a constant. This affects us, but it's a constant. We can't change it in the moment. For our airplane, we can't change this either. So we can't concern ourselves with the surface area of the wing. So really what we're concerned with are those two things. In other words, we're either changing the coefficient of lift or we're changing the velocity of the airplane. Namely, in this case, when we round out, this starts going down. What we want to do is, as this goes down, we want to slowly increase this so as to control the sink rate of the airplane. So we're controlling the sink rate of the airplane by, as the velocity of the airplane decelerates, we increase the coefficient of lift, in this case by increasing the angle of attack. If this isn't going down fast enough, or we controlled the airplane and we increase the coefficient of lift too quickly, we're going to balloon away from the runway. So that's what you're having to do. You're having to time the increase in the angle of attack or the flare attitude of the airplane in such a time that you can correctly compensate for the loss of velocity by an increase in coefficient of lift. That requires a deftness of control. And so if you're fighting the airplane, thank you. My wife brought me some water. Okay, that might help. Sorry about that. So if we're trying to time this perfectly, any kind of extra control loading, i.e. not being properly trimmed, is going to create complications. So again, don't forget those 2 to 3 wheels of trim, at least on short final. Okay. What if you do balloon? What do you do? Well, balloons, in my opinion, are kind of no-go situations. Unless you immediately recognize this, and I'll tell you kind of how you would recognize this, and immediately respond by some relaxation. You never want to push forward on the flight controls because, as I'll explain here in a second, a balloon can be a kind of a rock and a hard place situation. But relax the back pressure, then you need to go around. Because as I said, with a rock and a hard place type situation like a balloon, you're moving away from the ground while also rapidly increasing decreasing the airspeed, and in association increasing the angle of attack. So you're moving further and further away from the ground, which allows for more free fall distance, on top of the fact that you're moving closer to a stalled condition. The problem is if you unload the wing or lower the pitch, then the very thing that's kind of keeping you from rapidly sinking towards the ground, i.e. the lift that you're producing from the increased angle of attack, is gone. And so you can sink into the runway by reducing the angle of attack. And on top of that, you're going to sink with a flat attitude because you've lowered the pitch of the airplane. So you never want to push forward on the flight controls in a ballooning situation. So what does this really look like when this happens? Well, it comes back to that reference point down the runway. So if this is my nose and I'm looking down the runway, excuse my elementary drawings for anyone who's an illustrator. Let's bring it out a little bit more. Oh, that's even better. I'm looking down the runway. What ends up happening in a ballooning situation is this aim point starts to move, this reference point, I should say, starts to move back down. So in other words, we have a vertical sensation that as the reference point moves downwards in our point of view, then in accompaniment, we're ballooning away from the runway. In that situation, again, if you don't immediately respond by relaxing the control input you just applied, i.e. you just increase the coefficient of lift too much as you slow down, and you start to produce too much lift and start to climb back away from the runway, if you don't immediately relax that and reduce the coefficient of lift, then the balloon, of course, becomes more and more aggressive. That's a go-around in that situation because, again, if you lower the pitch to correct, now you could sink rapidly towards the runway in a nose low or flat attitude. There's really no way to correct outside of adding power. And unless you've practiced this, which again, landings are not meant to be saved, then it takes another kind of skill to save that landing, quote unquote. So the go around is the best option. Let's read what the Airplane Flying Handbook guidance has admittedly about this real quick. Depending, I don't know why this is not highlighted, it should be. So we're starting there. Depending on the severity of ballooning, the use of throttle is helpful in cushioning the landing. By adding power, thrust is increased to keep the airspeed from decelerating too rapidly and the wings from suddenly losing lift. This is another reason why it's beneficial to have your hand on the power at all times, because even low to the ground, you may have a situation, even if it's not a balloon, maybe there's a sudden gust of wind where the airplane begins to sink rapidly towards the runway. You can't solve that by just saving the attitude with pitch. You've got to add some power. So their recommended corrective action, and if I'm not mistaken, this is a written question, is if you were to bounce, or in this case, balloon back away from the runway, you want to fight the very desire to push forward on the flight controls. Instead, you hold the attitude you have, again, as they said, depending on the severity of the balloon, and you add power to arrest the descent rate to allow a proper sink rate towards the runway and therefore touchdown at a rate that's not excessive. But that in its own right takes practice. So if you haven't practiced this, and this is the first time you experience a balloon, let's say this is on your solo flight, you never had ballooning issues, and now suddenly you balloon because you have less weight in the airplane. And so you're used to a certain timing of that increase in coefficient of lift, or a certain timing, in other words, of rounding out and flaring, and you mistimed it just because the airplane isn't quite ready to land yet due to the lower weight compared to lift, and you balloon. You haven't practiced this. So the best solution is just to go around and do it again. You've done it enough times that you're going to get it right. Don't try to solve the problem that you haven't practiced. So just go around. That's your best solution in a balloon. And again, for me especially, this is my own personal opinion. Not every instructor would necessarily say this. This is a point of no return for me, for someone who doesn't have a whole lot of experience when it comes to ballooning. Just go around. It's your best option. All right. Let's get into our hard landings and our nose wheel concerns real quick. I'm going to take a drink of water. Give me just 1 second here so I don't lose my voice. Oh, great. All right, so as I talked about before, we can have preemptive notions about certain things when it comes to approaches, how to correct different issues like this. That being said, when we get into these circumstances, I will say that there's not a whole lot of ways for us to simulate this. We can talk about it. We can at least be aware of the situation. But there's not a whole lot of tools that I can give you that would apply across the board, except, as you guessed it, a go-around. So we're going to talk about these, but there's not a whole lot of corrective actions, as I said, that we're going to get into specifically, just because every situation has its own set of variables, and that set of variables can be, well, really truly infinite. So we could sit here and talk about it for days on all these different scenarios, this kind of crosswind, or wind coming from this direction as opposed to that direction, so on and so forth. So if we're trying to simplify things, we want to be aware of these complications that could arise on any landing, but especially if we're talking about solo flight, on what to do. We'll talk about some of the reasons why they occur and some of the aerodynamics behind them. But again, if I haven't said it enough, the best solution, of course, is to go around in any of these. So hard landing and nose wheel concerns, the subtitle there, of course, is simply awareness and apt correction. I think for a lot of people, when these things happen to them, they happen, of course, unexpectedly. You didn't expect it to occur. And if you've never talked about it even, much less, you haven't seen it, much less talked about it, then you have an even further problem, because then you don't even, of course, know what's going on in that moment. So awareness of these situations, and therefore, as soon as you recognize, hey, you know what, this is a porpoise, then I know immediately the correction, of course, is to go around. Don't wait. The longer you wait, the worse these situations get. They don't get better with time, they get worse. So we're going to talk about bounce landings. Most people think that a bounce landing is because you land so hard that the rubber air pressurized wheels cause you to bounce back off the ground. That's not true. That's really not the reason why you bounce back off the ground. It's aerodynamic, in fact. Flat and porpoising landings, we already talked about the danger of the flat landing. We'll emphasize that specifically in relation to a wheelbarrow, specifically in this case a porpoise landing, as well as a wheelbarrowing landing. And then just lastly, of course, some concerns about hard landings. There's nothing really specific that we're going to get to as far as hard landings in relationship to a particular situation, but just, of course, some of the concerns in relationship to that. So I know we've gone to the airplane flying handbook, but guess what? It's the place to go to really delve into these areas, and it's where, of course, we get all our information from. It's what an instructor teaches from, really, or what they should do, and certainly the basis for where we get a lot of information that guides us on how to perform properly in conjunction with the Airman Certification Standards. So let's jump back into that. Okay, so bouncing during landing, bouncing during touchdown specifically, this could, of course, have any different number of reasons why this happened, but what it boils down to, of course, is an excessive rate of sink. A lot of pilots, of course, tend to internalize this, but be aware that this could happen to anyone with any kind of level of experience in any situation. I remember watching, there was an old reality TV show called Airplane, I think. And it was about Southwest air carrier. And one of the episodes was following a retiring captain. He was on his last flight, and he had 25,000 flight hours. And the interviewer asked him what he was looking forward to that day, and he was like, "Oh, I'm looking forward to hopefully mastering landings today." So in other words, it can happen to anyone when it comes to any type of these situations that we've discussed. And bouncing certainly can happen to anyone, even if it has nothing to do necessarily with technique. You can have a sudden shift in wind that causes a sudden sink rate to increase. Namely, in this case, let's say that you have a headwind that suddenly shears to a crosswind. Well, as that headwind shears to a crosswind, all that lift that's being produced by that headwind component is instantaneously taken away, And the airplane's lift component, of course, is suddenly reduced and the airplane rapidly sinks to the runway. So if this happens, especially at low altitude, there may not be enough time to react, and in conjunction could lead to a hard landing that leads to a bounce. The good news is, especially for these training airplanes, they're really built for hard landings, especially, of course, well, specifically, of course, if they're done properly, namely on the mains. What actually happens, though, as far as the result of a hard landing is, as we can see here highlighted, instead it rebounds back into the air because the angle of attack was abruptly increased, producing a sudden increase in lift. Namely, what ends up happening is as you make the hard landing, the momentum causes the airplane to shift, or in this case, it's inertia, as you can see in the following paragraph, shift to cause the airplane to move tail downward. And what happens when the tail goes down? Well, the nose goes up, of course, in association, and so the angle of attack is increased. So we suddenly have an increase in lift in conjunction with this, and this increase in lift would be enough to cause the airplane to start to fly back into the air. What's the problem? It's the exact same complication as we see with the ballooning situation. We are now back off the ground and moving back away from the runway, climbing away from the runway while simultaneously rapidly losing energy. So we're approaching a stall situation as we move vertically away from the runway. So the secondary landing would be much worse than the first one if we don't appropriately correct. So what does the AFH say for correction? Probably you can already guess what it's going to say. The corrective action for a bounce is the same as the balloon. And it depends, of course, on its severity. So you could do one of two things according to the AFH. You could follow up by applying enough power to cushion the descent rate for the second landing. If you've practiced that, which again, as we've talked about, landings are not meant to be saved. So our best option is to go around. It's really our only option in this situation. And quite simply put, that's as far as we're going to go into it. So like I said, there's lots of different reasons why you could have a hard landing, rounding out too high, misjudging your descent rate, late and rapid round out that leads to an accelerated stall, or a gust of wind. Whatever the reason that leads to a hard landing, the best solution is as you bounce back off the runway, as the angle of attack is increased, just go around, do it again. If you landed on the mains, it's very likely you didn't hurt anything. And of course, just to reiterate, I know you all know it by now, when a bounce is severe, the safest procedure is to execute a go-around. Okay, porpoising. What in the world is porpoising? Well, yeah, it's named after dolphins. The complication in a porpoise is much worse than pretty much anything we've talked about so far because of its automatic state nature. In other words, a porpoise basically starts to develop and continues on its own without any pilot control input. Let's talk about, of course, what it is. So the AFH says the porpoising can be caused by improper airspeed control, in this case, namely a too fast approach airspeed. And in this case, as we talked about before, the pilot tries to force the airplane onto the runway when it's not ready to land. So what ends up happening, and it doesn't even have to be as agitated as we see here initially. It can actually be quite subtle at first and become worse and worse over time. So let's say that we're trying to make our short field landing. We're on our check ride, and Ed's sitting next to us, and we're sweating bullets. And we're like, oh, man, this is not working out. This isn't working out. I got to make this happen. I can't fail this check ride. And we recognize that we're shooting past our aim point.
Thanks, Evan.
No problem. And we start to round out over our actual touchdown point. And we're like, oh, I've only got 200 feet. I got to put this airplane down. And so we touch down, maybe when we touch down softly, but we touch down on all 3 points. And the problem, of course, with that is at that point, if you touch down on all 3 points and you have an excessive amount of airspeed, then you have an excessive amount of lift. The slightest increase in angle of attack, of course, can cause the airplane to balloon back away from the runway. But the other thing that can begin to occur is, let's say that you even touch down slightly nose first. Then what happens is as you hit nose first, just slightly, that causes the nose to bounce back up, which causes an increase in angle of attack, and then you hit the mains. So you come back off the ground just a little bit the first time. Then you come back down again and you hit nose first again, except this time the oscillation's a little worse. So the nose hits a little harder this time, which causes a harder bounce onto the mains, which increases the angle attack even further. And you get where this goes. Those become more and more aggressive and more agitated, which can lead to a multitude of different issues. Loss of directional control, to name the least of them, but eventually can lead to a prop strike or even a failure of the nose gear itself. At any point in time, as soon as you recognize, to be honest, if you recognize you landed flat, a go around, of course, should have already been initiated. But if you begin to see this occur, where you begin to see an oscillation between the nose wheel and the mains, there's no way to stop it except to basically go around. Now, the AFH will also say that you can raise the angle attack, which is true, but once again, that takes a deftness of touch that we don't need to practice for. So the easiest correction is simply to go around. Again, how do we avoid this? We avoid this by avoiding fast approaches. If we come in fast and it doesn't look right, we go around. I don't know why it's writing when I'm telling you not to write. Gotta love software. Please stop writing. Okay. On that note, let's see if I can close this and open this back up, and that will solve the problem. There we go. Okay, so if you haven't already seen it enough, guess what? When a porpoise is severe, the safest procedure is to execute a go-around. I will say the AFH says the corrective action for a light porpoise is the same as a bounce. You hold the angle attack by keeping the back pressure in, and you add enough power to cushion the subsequent touchdown. But for us, just go around. It's so much easier. Doesn't take precision of control inputs that we haven't practiced. The other complication with a flat and fast landing is a wheelbarrow. This is a situation where you literally do just what it sounds. The airplane turns into a wheelbarrow. In other words, the weight of the airplane becomes so distributed up onto the nose wheel that you are on the nose wheel solely, or maybe even if not truly, most of the weight is distributed to the nose wheel, which can create a multitude of complications, which the biggest one, of course, would be is your directional control. We talked about before how it's much easier to directionally control the airplane when the weight is off the nose wheel, or especially if the nose wheel is off the ground. This is the exact opposite. It's the antithesis of that concept. This is usually because of this situation. You come in fast. Maybe you chose to land in a situation where you didn't feel comfortable with the circumstances. The winds were excessive, whatever the reason. You're coming in fast. You didn't manage the airspeed properly. You land flat and fast because you're just so nervous about the situation. And in so doing, you give up on the back pressure, right? Because we want to relax in that situation. Oh, I'm on the ground. It's over. When I relax that back pressure even further, we can push all the way forward on the flight controls with this specific type of airplane. That distributes the weight onto the nose wheel. And in this situation, as I said, it can turn into a wheelbarrow. At that point, you're literally pivoting on the nose wheel. So imagine the directional response of the airplane in that situation. The slightest control input could lead to an excessive response on the airplane and make it very difficult to control the airplane, especially as we see in the AFH in crosswind conditions. So let's just read that highlighted area. Wheelbarrowing may cause loss of directional control during the landing roll because braking action is ineffective. You don't have brakes. And the airplane tends to swerve or pivot on the nose wheel, particularly in crosswind conditions. The airplane wants to weather vane into the wind, and it's pivoting on its nose wheel, so it's going to do so much more aggressively than it would do otherwise. So what do you do in that situation? Well, you've got to get the airplane, of course, off the nose wheel. How do you do that? By increasing the angle attack. The complication, of course, is you may be going so fast that as you increase the angle attack to raise the nose and lower the mains, you may start to fly off the runway. So if you didn't already guess it, a go-around would be the most prudent solution. And we can see once again, one more time, the AFH says that that is a good idea. If it's not an option, because you're so much on the nose wheel, you could close the throttle and pull back on the flight controls to get the airplane back in an appropriate attitude. Once again, to avoid this, as we've kind of talked about, these are situations where it almost takes deftness of control to really properly respond to them. when in doubt, the go around is your best solution, because we can't really go out and simulate these safely per se. So the only real way to get awareness across, of course, is discuss them. And therefore, we can't do a whole lot of practice. So therefore, the go around, and once again, I know I said it again, I'll continue to say it, is your best option. Okay. I think everybody has an idea, of course, why hard landings are a concern. The exact opposite, actually, I want to emphasize is the importance of don't be afraid of maybe not what we call a hard landing, but don't be afraid of a firm landing. We all like to judge each other based off, because, you know, that's one of the easiest ways to judge, especially for a non-pilot, is how soft the touchdown is. But let's kind of talk about a soft touchdown. A soft touchdown occurs when you've perfectly varied. Remember when we were talking about the coefficient of lift compared to the velocity of the airplane? What you've really done in that situation, if you've had a soft touchdown, is the weight of the airplane is so perfectly distributed to the lift of the airplane that they're pretty much exactly succinct in that moment, so that when you touch, weight and lift are succinct with each other, so that any increase in lift may cause the airplane to actually balloon back away from the runway. I usually teach that in gusty wind situations, a soft landing is not really what you're looking for. You want to put the airplane on the ground and know it's not going to come back off the ground. So you want to stall the airplane in. That, of course, comes back to the idea that we stall the airplane in with an appropriate attitude. So we do want a hard landing, but of course we want a hard landing at the appropriate distance. So this is, of course, is no surprise that the AFH talks about the importance of this cushion may be understood from the computation that a 6-cent free fall on a landing is roughly equal to 340 feet per minute descent. So if you think about that, that's still fairly significant, but you're not hurting the airplane. So don't be afraid of stalling the airplane in on the mains, and don't think it's a failure. I would specifically say when you have a good firm landing on the mains, nose well up, and you're properly aligned over the center of the runway. That's pretty much exactly what we're looking for. Can you make soft landings and those, you know, get a golf clap from your instructor and everyone else? Certainly, but don't think it's a failure when you make a good firm landing on the mains. As I said before, what that tells you in gusty wind situations especially is the airplane is not ready to fly again. So if you have a sudden shift in wind where you get an increase in headwind, you should not have a surprise where the airplane suddenly wants to climb back off the runway because of how close you are in your lift to weight distribution. That being said, of course, we do want to be aware of high altitude free falls and the damage that it can incur. I'm not going to go into the details, of course, about that, because I think everyone has a good idea that they would want to avoid that. The key takeaway with this situation, once again, is we talked about it before. We'll talk about it once again here now. We want that hand on the throttle, but remember to keep your body loose so that you can aptly respond to these situations. If you have a sudden increase in sink rate that leads to a situation where you're likely to impact the ground hard, even in a nose-up attitude, don't hesitate to utilize the power. The power can be utilized to arrest the descent, but more importantly, you can be ready to go around. I see a lot of stiffness of control when people are struggling with landings. So as I'll talk about here and again with my tips and tricks, you want to always try to remind yourself on every approach to keep your body loose, because in hard landing situations, it wasn't for a lack of intention for the pilot. It's usually a lack of response, or more specifically, a timely response. And timeliness comes back to being able to be relaxed enough to be able to apply those control inputs quickly. And in this case, the power is usually going to be your best solution, because if you increase the angle of attack when you're rapidly sinking towards the ground, that usually is only going to increase the angle of attack. And it does lead to a situation that I'm not going to delve into tonight, which of course is the concern about tail strikes, where you've over-rotated the attitude of the airplane and you risk striking the tail of the airplane either before the rest of the airplane, which would be really bad, or even simultaneously or even slightly after. All right, so let's take a look at just one more thing real quick before we go on. Directional control. Most people, if they struggle with something when it comes to the landing as a whole, if I were to apply it across the board, is actually usually directional control. Namely, in this case, we're talking about not just during the approach, but even during the round out, the round out, the flare, and especially the rollout. So awareness, preparation, practice, being aware, of course, of the situation. Remember how we talked about earlier about how some people struggle on the progress checks when they're not aware of the wind. Wind, of course, is usually one of the biggest complicating factors when it comes to directional control, especially early on, of course, when you may have a crosswind from one direction one day and a crosswind from the other direction the next day. So we always want to be thinking about the wind, and we always want to be mentally prepared for what we're going to do before we do it. I think that's one of the biggest shortcomings, is people want to habitually respond early on in their training, and that just doesn't happen. So I always tell people, if you're doing things right, you're kind of going to feel maybe not physically exhausted after a flight when you've done things well, but maybe mentally tired, because you've been constantly reminding yourself, okay, this is what's going to happen at this situation, and this is how I'm going to respond. This is particularly important because it makes you a proactive pilot rather than a reactive pilot. In other words, the difference between a proactive pilot and a reactive pilot is kind of the difference between someone learning to fly the airplane when it comes to coordination using just the skid slip indicator. In other words, they wait for the skid slip indicator to deviate or deflect before they make a rudder input. Whereas a proactive pilot has learned the aerodynamics behind what will make the airplane uncoordinated and knows when to apply rudder before they become uncoordinated. And then in that factor, they only use the skid slip indicator to precisely adjust whether they need to make a modification of their control input, not the change itself. So in the same way, we can become proactive pilots when it comes to directional control by thinking about the wind, and not just on the flight itself, not just in the airplane, but on the ground, going through different scenarios. What's going to happen when the wind is from this direction? What's going to happen if it suddenly gusts? Is the airplane going to turn into the wind, or is it going to turn away from the wind when the wind speed increases? When you think about these things, they become more habitual. And that's the whole key. As I said before, when it's early on in your training, you want to just kind of do it reactively, naturally. It won't happen. So you've got to be cognitively thinking through these processes before they happen. That's what I mean by awareness and preparation. Knowing what's going to happen and knowing how you're going to react to it. So we're going to talk real quick about touchdown and adrift or crab. We're going to talk about the wing rising after touchdown. And like I said, I'll mention what a ground loop is, but not talk about it too much. Those are my tips and tricks, which we'll finish with here in just a second, but let's jump back in one more time to the Airplane Flying Handbook and see what we have to say about those sections. Hopefully I can make it through without losing my voice. Okay, so touchdown and adrift or crab. Most of y'all have probably seen this at some point in your flight training or in your flying experience. What is, in my opinion, the most common reason across the board for people touching down and adrift? I don't think it's for a lack of skill. Skill is definitely something to be said, but I think it's usually more distraction. So what do I mean by that? I mean the distraction of all the other things we just got through talking about. You're focused on timing the round out. You're focused on maintaining your airspeed. You're focused on looking down the runway or reducing the power by walking it back smoothly so you don't increase the sink rate of the airplane. Or more specifically, most commonly, you're focused on timing the round out and the flare, and you become so focused on that that when you touch down, you're like, hey, the center line's over off my right-hand side. It was in between my legs just a moment ago. That's what I mean by distraction. It's the inability to divide your attention readily between everything going on at the same time. Now, there's a limit to that, especially in stronger winds. Most people will begin to, without enough experience and ability, struggle with the proper control inputs, in this case, namely the proper aileron and rudder inputs. So how do you solve for this? I would recommend, if you haven't already done so, I referred to it before, do some slow flight down the runway. Intentionally go out when there's a direct crosswind with your instructor. Even if you're a licensed pilot, if you don't have confidence when it comes to crosswinds, and do some slow flight down the runway, practicing correcting for the wind. And once again, as I said before, give yourself the license to experiment. Intentionally allow the airplane to drift. See what kind of control input reduction you had to apply before it allowed the airplane to begin to drift. See what kind of control input will allow you to actually drift into the wind, as opposed to just necessarily maintaining the appropriate control input. Develop more feel, in other words, for the controls in that regard. Be aware, of course, that as you get slower, that control input, of course, increases at the same time. So it's not a consistent control input. Remember how we talked about the power not being the same at all times? You don't expect in a crosswind situation, your control inputs are the same at all times. If you ask someone that's proficient in this, you ask them, how many degrees of deflection did you have on the ailerons? They're not going to be able to tell you that. They just feel it out. So in the same way, you need more experience filling out what is correct and is incorrect. The problem with a normal crosswind landing is you have just a matter of seconds to be able to fill that out. So give yourself more time by practicing crosswind corrections with some slow flight down the runway. Another option is your instructor can actually take control of most of the responsibilities except for the directional control ones, i.e. they can control the approach angle with the power, the pitch to control airspeed, and then as you get over the runway, all you're doing is just keeping you over the runway while they do everything else. There's lots of different options there to give you more exposure and more experience with that. Why do I recommend these specifically? There's no doubt that there's a complicating factor, especially for someone who's not used their feet a lot in any other aspect in their lives. We don't use our feet for much when it comes to directionally controlling any type of machines, and so it's not something we're used to. So we need more exposure there. On top of that, don't forget that when you make your correction, this is my personal recommendation, I recommend that when you're first applying your wing low or your crosswind correction, don't hesitate to straighten the nose first with your feet. And why do I say that? It's in my experience that what most people will do is they'll do okay with their hands, but their feet will lag behind. You can call it lazy feet, but what I really think it is people are just not confident. They don't have that feel for the proper control input. So if you lead with your feet, usually what happens is you habitually respond with your appropriate hand control input on the ailerons. Whereas the opposite, if you lead with your hands, if you lag with your feet, your hand usually immediately kind of takes the correction right back out, because what ends up happening is you start turning away from the runway instead of course, correctly applying the appropriate rudder input. So it's my opinion that you apply the rudder first. Your hands will usually follow more habitually in response. That being said, let's talk about what we came here to talk about, which of course is the danger or the concerns of touching down in a drift. If you've ever experienced this, it's pretty jarring. In fact, some people that don't even notice they touch down in a drift, they recognize it as a harder landing. Why was that landing so hard? It didn't seem like my flare attitude was improper or we were too high above the runway. What they didn't notice is that they were touching down in a side load. And of course, that's the concern, is that touching down in a side load, this can of course damage the tires, wear the tires out if nothing else, and reduce their life expectancy. Harder landings, of course, as well. But it also creates the concern, of course, of drifting away from the center line and not touching down in the middle of the runway, particularly a concern from a airman's completion standards, but also obviously on thinner runways, you don't have a whole lot of runway to play with in the first place. And clearly it just demonstrates good airmanship. If once again we're evaluating someone's abilities, if they intend to land in the middle of the runway, then that's where we should land. The AFH says, of course, in the highlighted area, if the pilot does not take adequate correction action to avoid drift during a crosswind landing, the main wheel's tire tread offers resistance to the airplane's sideward movement in respect to the ground. This can consequently lead to this situation we see here, which is a ground loop, but we wouldn't necessarily even get to that. So as you touch down in a side drift, i.e. as the airplane is drifting this direction, the tires will grip the runway and cause a shift in the load of the airplane, and the airplane begins to pull this direction. If it really gets bad, the airplane can, because of its momentum, if you think about a top-heavy airplane, which of course in a high-wing airplane we are, the weight of the airplane will actually cause the airplane possibly to tip, and that's what they're showing us here is a possible wing strike in association. So there's a multitude, of course, of concerns that go even well beyond your basic light side drift of wearing out the tires. So clearly we don't want this. The corrective action in this type of situation, if it's bad enough, is, you guessed it, go around. But what if it's not so bad? Well, this is the other problem that I oftentimes see, of course, is the ability to change your mindset. And that's admittedly one of the harder things about this in a crosswind situation is we take an airplane and we use a certain amount of control inputs prior to touchdown, and suddenly those change. Namely, when we're in the round out and the flare, we're using our rudder for alignment. And we're using our ailerons for position. But suddenly when you touch down, those almost reverse. So this is in the air. Now suddenly you've got to change your mindset that when you touch on the ground, the rudder now is used for directional control. Or you could also say technically position. And the ailerons are for stability, for the crosswind. So you have to reverse your mindset. And especially if you haven't had a lot of experience using your feet, this can become complicated. So the response, of course, especially if you touch down in a side drift, is to avoid the further complication that we'll talk about here in a moment, which is a wing rising during rollout. And the way we avoid that is we've got to continue to deflect the aileron into the winds. When in doubt, go nearly full deflection if it's bad enough. But certainly as we slow, we know that we will need more deflection to increase the control response, or in other words, to correct for the crosswind that might otherwise lift the wing. So when in doubt, go around. Otherwise, as a rule of thumb, what you should be doing anyways would be increasing the aileron deflection and keeping the nose straight initially, because the airplane is going to tend to weather vane into the wind. You do want to move back towards the center line, but you don't want to do so at such a rate that it could create this type of situation and lead to a swerve or a moment that pulls the airplane over on its side and possibly risks a wing strike. So you generally want to maintain directional control, and that may mean using left rudder, which is counterintuitive initially, in this case with the crosswind from the right, to keep the airplane just stable and then allow the airplane to move back over to the right once you've regained control of the airplane. Once again, this requires practice, which means that the best solution in this situation is to go around when you don't have a whole lot of practice. So a ground loop is kind of the extreme of this situation, where we can not only encounter this, but the airplane can literally spin around and do a 180 on the runway. In other words, fishtail around is really what it boils down to. Once again, not to come in tricycle landing gear airplanes, but can occur. So if you start to see the airplane swerve, again, your best solution in most cases, at least at faster speeds, is to go around. And I would say that the earlier you do this, the better off you're going to be. Okay, so what about a wing rising during a rollout or after touchdown? This usually occurs, of course, because the upwind wing, or in other words, the wing on the crosswind side, of course, is lifted by the wind on that side. As soon as it lifts, the angle of attack increases. And if it increases, of course, in angle of attack, what's going to happen? The lift is increased. So it doesn't get better. It actually gets worse without pilot response. This all usually happened, of course, because of either A, we didn't apply enough control input in that direction. In other words, if the crosswind is as depicted in this visualization, either on to the right, but it also could be even worse. And this is another situation that can arise that I've seen happen when directional control issues come about. We talk about habitual response. If the airplane were to veer to one side or the other and we inappropriately correct with the ailerons, let's say that, for example, we drift to the right in this case instead of what's visualized here to the left, i.e., let me quickly illustrate that. So if the airplane begins drifting this direction after touchdown, maybe because of wind, or maybe in combination because we haven't fully put the weight of the airplane down on the runway, maybe we're misaligned directionally, whatever the reason. And let's say as the airplane drifts this direction, we habitually respond incorrectly with left aileron instead of left rudder. In that moment, you're doing this reactively, not necessarily cognitively. And in that moment, if you do that and the inappropriate response is, it's not doing what I want it to do, your brain might get confused and shut down in that situation. Then you get confused on top of that with what to do with your rudder pedals in association. So all the more reason that you already have this pretty much set up on final. And you generally, therefore, are going to stick with this no matter what happens. Ed has a great story about an icing situation on a runway that proves this point. I'll let him tell that to you. But the point is, we want to always think aileron into the winds. And at that point, when we touch down, tell yourself, dance on the pedals if you need to remember, I'm going to directionally control the airplane with rudder while just keeping the aileron deflection into the wind. This is easier said than done because, as I just talked about, there's that peculiarity of the fact that the airplane was being controlled in one aspect just a moment ago, and now it's controlled in a different way now that we're a ground vehicle, if you will. But with enough practice, of course, this will become habitual. It's getting to that point is the key, and in my opinion, the best way to get to that point is, even if you need to say it out loud, when the wheels touch, okay, I'm going to control the airplane direction with rudders at this point. Get your mind thinking that, and especially, like I said before, be ready to preemptively set yourself up for that rather than depending on that habitual response that, again, will come with time, but only comes with enough practice and enough experience. Okay, that's it. So let's just take a look real quick. I'll finally let y'all go. I guess I'm actually on time, which is surprising. Let's take a look at a couple of tips and tricks that I recommend. These aren't absolutes. You won't necessarily find these anywhere in the airplane flying handbook or anything like that. You will see some of these certainly emphasized at the school, however. So let's just talk about them together. I always recommend, in fact, this is not a recommendation. This is just straight up requirement. If you get out of the habit or you've forgotten about it or you're not emphasizing it to yourself enough, make sure you're always setting your seat height before every single flight. The seat height position is absolutely key for proper sight picture. This could be creating some problems specifically with roundouts, rounding out improperly. So generally speaking, the eye line as you look should be in line with the door seal. When in doubt, however, it's better to be high than too low. So in other words, if you sit too low on the seat, that's kind of the worst case scenario. It really messes up sight picture for proper round out and flare. Two, I talked about this before. If anyone is stiff on the controls, and you may not even recognize this, and if you haven't had this conversation with your instructor, ask them, do I look like I'm iron gripping the controls? How do my legs look? How does my forearm and my bicep look? If you're stiff on the controls, get your body relaxed. Easier said than done, I know, because you want to make a good landing, so that becomes a little bit agitating. But even taking some deep breaths, maybe is a standard operating procedure on the base, 3 deep breaths. And on final, relax the body, roll your shoulders back, sit back into the seat, try to be aware of not leaning forward, tensing your muscles. It seems counterintuitive, but again, the more relaxed you are, the more apt you're able to make those quick control responses. Set a hard deck. Remember, stay consistent with your no-go point as far as a go-around goes. Our SOPs call for a 300-foot go-around. If at 300 feet you're not on a stabilized approach, go around. And by the way, that's not just at 300 feet, that's at and below 300 feet. So at any point in time below 300 feet, the approach becomes destabilized. A go-around is called for. 4, we've got correct early. We kind of talked about this before. By getting your control inputs practiced early on the approach, that helps you to mitigate the issues that could come about close to the ground. If you think about it, the whole reason why we have a final is to give you time to set up for the approach. You don't want to be making all these corrections short final. So yes, there's some schools of thought specifically with crosswind control inputs that you should do it as you round out. But once again, when you're first practicing, it's better to get those control inputs felt out early on the approach. We talked about leading with the foot. There's that exact same concept. It gives you time to practice that control input early to get it done early. In the same regard, correct early, once again, with mental preparation. Think about what you're going to need to do as far as the crosswind goes. Think about where you're going to reduce your power. Think about when you're going to time your eyes out towards the end of the runway. As I said before, timing the eyes in the runway is usually coincident with your reduction of power to your aim point. Practice your procedure. So as I just talked about, if someone asks me, how do I land the airplane? I can explain them when I look where, when I reduce the power, when I apply control inputs, what's telling me that when to apply those control inputs. You may not necessarily need to be able to explain that to someone word for word, but you should be able to say that to yourself, at least in your head. You should be able to recall almost a memorized procedure of things that are going to give you cues as to when to do what. If you don't have that, you need to have that. If you don't know how to get that, ask me, email me, come in for tutoring. We can talk about that. Anything to help you figure out a procedure that works for you, coincide it with our SOPs, coincide it with general rules of thumb that are applied from the AFH. I guarantee you this is going to help you, because again, if you have a mentally rehearsed plan of action, it's not going to immediately translate to muscle memory, but it does put you several steps ahead of the game, as opposed to kind of what I call guessing or hoping for the best. Lastly, when it comes to that issue we talked about with the low round out or the late rapid round out or the high round out, don't pressure yourself into thinking you've got to land the airplane now. You've got time, and that time is the round out. So what I've been telling people lately is think like if you're just going to do a low pass down the runway, like as if you were an air show pilot, you're going to smoke the runway. Your first thought process is rounding out over the runway to dissipate that energy. You've got time to dissipate the energy before you come in for the flared attitude. If you do that, if you think that specifically, I usually see people rounding out at the appropriate altitude. Namely what we talked about before, that altitude that allows you that reference to determine when it's time to begin to rotate the attitude, that extra 3 to 5 feet of altitude, if you will. And that will make a load of differences. It's been my experience that if people time the round out properly, the flare almost comes naturally. And so it's usually a mistimed round out that leads to a mess up in the flare. A lot of people perceive it as an issue with the flare, but in reality, it's usually a mistimed round out. All right, I know I've kept everybody here for 2 hours. It's almost 9 o'clock, so everybody, you're welcome to go. I'll stick around for maybe 5-10 minutes and answer questions. If anybody wants to ask questions to me privately, you're certainly welcome to email me. We can set up a separate time, or again, we have tutoring every single day of the week for now, Monday through Saturday, 1 to 3. You're welcome to come in and ask literally any question. It doesn't even have to be pertinent to a curriculum. It could be anything about your training. It could be anything that you want to talk about aviation, period. Some people may just literally be, kind of lonely right now because we're all having to stay at our homes by ourselves maybe. Welcome to come in and just talk aviation. So by all means, welcome to do that. So anybody that wants to leave, you're welcome to leave. Anybody that wants to stay,
Evan, I want to say something before you wrap things up.
Say again?
I want to say something before you wrap things up.
Okay.
I just want to thank you for putting this on. This was an awesome presentation. And I just have to do this because Jacob is online and he hasn't heard this in a few days. So here we go.
I think it was that of my flight instructor saying, you can always go around.
No. No.
Just had to do that for you, Jacob. He hears that like 10 times a day in the office, but I thought it was appropriate. But seriously, Evan, great job. Thank you for doing this. I hope everybody picked something up from it. And if you ever want to hear that story Evan was talking about, just ask me sometime. It was a day where somebody wrecked an airplane, but I didn't because I did what Evan was talking about and the other person didn't. So